So you are having I is equals to, it is integral of e power of 2x minus e power of minus of 2x divided by e power of 2x plus e power of minus of 2x into dx. So we need to integrate this one. Now the question is, if you try to observe the previous example that we have done here, what we have done, we have divided by e power of x, because if you try to differentiate the denominator, we were not able to get the numerator. And when we differentiated the numerator, we are not able to get the denominator. Therefore, what we have done, we have divided the numerator and denominator by e power of x. Now the question is, should I follow the same method for this? That's the question. But if you try to observe over here, in this example, you had the first term as this e power of 2x, denominator first term you had e power of 2x, whereas the other two terms were only 1. Therefore, this condition failed in both the cases. We are not able to put the value of the numerator or denominator as t, because one term was in terms of e power, the other term was in terms of the constant 1. But if you try to observe over here, all the terms are e power of 2x only, but they are a positive and negative value. Therefore, in this case, you might get from the denominator, you can get the numerator value. Let us just try to check whether this will work or not. So put the denominator value e power of 2x plus e power of minus 2x is equals to t. Let us just check it. If this fails, again we'll go back to the previous problem method. So let us try to see whether we'll be getting the numerator or not. Differentiate this one. So e power of 2x will be e power of 2x itself into differentiation of this 2x will be 2 plus e power of minus of 2x into differentiation of minus of 2x will be minus of 2 into the derivative of this x will be dx is equals to, on the right hand side, derivative of t will be dt. But if you try to observe over here, 2 is common. I can take 2 common outside. I'll be left out with e power of 2x. Here plus into minus will be minus e power of minus of 2x into dx is equals to dt. But if you try to observe over here, you don't have 2 multiplied. So it is better you try to cross multiply this one. Therefore, you will be getting e power of 2x minus e power of minus of 2x times of dx will be equals to dt. Cross multiply the 2 divided by 2. Now it is nothing but the numerator value itself. You can observe. So in this case, there is no need to divide by e power of x as we have done in the previous example. So you need to judge whether whatever you use for this problem, will it hold good for this problem or not? It will not hold good. So this problem is quite different. Now if
The
you try
method
to,
is different, right?
yes,
So you can't do the same thing.
yeah, you cannot do it. Even if you try to do it, what happens is you'll not be ending up with any conclusion there. Again, you have to again put e power of x plus e power of minus of x as t, so that the step that we'll be doing will not help you. Let us try to see whether it will work or not. So you have done what you have done, you have divided by e power of x, right? If you divide it, what happens is you'll be getting e power of 2x minus x will give you x minus e power of minus 2x will give you minus 3x. Because e power of minus 2x and this minus of x whole divided by denominator value, if you try to divide it, it becomes e power of x plus e power of minus 2x minus x will give you minus 3x. Now if I try to put this denominator as t, you'll be getting the numerator value, right? Whereas when you're able to get directly, why do you want to go for this method? It is a waste of this step that you'll be doing when you are able to do it directly. When to use this one? Only when you try to differentiate by taking t, you should not be able to get the dt value, that numerator value. When you take the denominator as t, you should not be able to get the numerator value. Only in that case, you have to adopt this procedure. Otherwise, you have to follow the normal procedure. Getting it? So first you have to check it. Here also we have checked it, right? I tried to follow the normal procedure here. in this case, I tried to follow the normal procedure, right? First I checked it, but I was not able to get that value there, the standard value that I wanted. This was not there in the numerator value, because along with e power of 2x minus 1 was there, minus 1 was not coming here. Because this failed, therefore I went for this step. So first you have to check whether that step will pass or not. If it doesn't pass, then you have to go for this one. Getting this one? So now let us try to substitute it back there in the given integral. You'll be getting I is equals to, the numerator value will be dt by 2, and it is whole divided by denominator. What you are having, I have taken the denominator as t. Denominator as t. So however, this 1 by 2 I can take outside and write down integral of dt by t. But integral of dt by t will give you log of t plus the constant of integration c. But what is the value of t I have taken? I have taken the value of t to be equals to e power of 2x plus e power of minus 2x. So therefore we'll be getting 1 by 2 into log of e power of 2x, e power of minus of 2x plus the constant c. So that will be the required solution.